So we're going to be looking at the study guide for the chapter 7 through 9 test for a 6th grade class. So we start with two word problems. So the first one is a car is traveling at 65 miles per hour. Write an equation to represent the miles the car drives in terms of the hours being driven. So basically this is asking for that something equals something equation that we've been working on. And usually you have to identify which one's your independent, which one's your dependent, and all that stuff. So as a rule of thumb, time is almost always going to be your independent variable. So in this case, hours, we'll call h, is my independent variable, and miles is my dependent. Again, time being independent in most cases. So it says we're driving 65 miles per hour. So the word per here means that this 65 is going to be my multiplier number. So it's going to be 65 times some variable equals some other variable. So 65 miles per hour, which means that every hour, every h, I'm going to go 65 miles, and that will give me my total distance that I'm going to travel. So every hour, h, I go 65 miles, and if I do that calculation, I'll get the total amount of miles that I drive. And so this right here would be my equation, h times 65 equals m. Again, the per word there is going to be the number that's attached to the independent variable. And the dependent variable, in this case miles, is almost always by itself. Same thing for the next one. So an ice cream store sells ice cream at a rate of $1.50 per pound. We want an equation that gives the total cost in terms of the pounds. So in this case, pounds is my independent, and the cost is my dependent. So the cost and the pounds are my independent and dependent variables. So in this case, the cost is equal to $1.50 per pound, or $1.50 times pounds. So this would be my equation here. C equals 150 times P, because it costs you $1.50 per pound of ice cream that you buy, and so it's 150 times P. The next part is the same thing, just dealing with the equation rather than a table. So it says use the tables to write the equations. You just need to find the rule of the table. So if we look here, we go 1 to 6, 2 to 7, 3 to 8, 4 to 9. Every time we do that, we're adding 5 each time. So my equation is y is equal to x plus 5, because I add 5 to the x every time to get my y counterpart. Same thing for the next one. 0 to 0, 4 to 12, 6 to 18, and 8 to 24. Now I can't really add anything because 0 plus like 1 or 2 is just going to give me 1 or 2, so 0 to 0 wouldn't work. So it has to be multiplying by something. So in this case, if I want to go 4 to 12, well, I can times by 3, and that gets me 4 to 12. And I can times by 3 here, and that gets me 18. And I can times by 3 here, and that gets me 24. And I can times by 3 here, and that gets me 0. So in this case, multiplying by 3 would be my rule here. So the way I would say that is y is equal to 3 times x, or 3x, however you want to write it. So you just have to kind of play around with it a little bit, look at your table, try some addition, see if that works. If that doesn't work, then do some multiplication instead, and hopefully that will cover the missing bits. On the next page, we have same type of problem, but it's a little bit more advanced. We have a table, and we want to figure out not only the equation, but then use the equation to figure out how many widgets that we're going to sell. So the first thing, though, is to figure out our rule for the table. So we have time, we'll call H for hours, and widgets we'll call W. So time is H, widgets is W. So what do I do to time to get the widgets? So what do I do to my time variables, my time numbers, to get widgets? Well, again, adding is not really going to work. You could do 2 plus 22 is 24, but 4 plus 22 is not 48, so we have to go to multiplying. In this case, it's timesing by 12. So 2 times 12 is 24, 4 times 12 is 48, 6 times 12 is 72, and so on and so forth. So timesing by 12 seems to work. So we need to write that as a rule, as a formula. So the number of widgets you sell is equal to 12 times the amount of hours that you spend. So 12 times h gives you the number of widgets you sell. Again, that's just formulating the rule from what we just saw here. So we took the 2, we times it by 12, we got the 24. So it's h times 12 gives you your w. That's kind of the routine you follow. You take h, you multiply it by 12, you get your w. But the second part says how many hours will it take to sell 100 widgets? So in this case, we have 100 widgets. So 100 represents the number of widgets that we have. So I'm going to put that 100 in for w. Keep everything else the same. Because my question says, well, you know how many widgets you're going to have. You're going to have 100. Let me make that h a little better. So how can you find out how many hours it's going to take to get this 100 widgets? Well, h is the variable I'm looking for. Right now it's being multiplied to this 12. So in order to get rid of timesing by 12, I'm going to divide by 12. Because if I multiply by 12 and divide by 12, that's just going to cancel out. And over here, I have to do the same thing. I have to divide by 12 there. So I have to do 100 divided by 12, which gives me about 8.33 hours, or 3 repeating if you want to do the bar. So when you have a word problem like this, you have to not only make the table, but then you have to find, or not only make the equation rather, you have to use your equation to find that missing value. In this case, the missing value was trying to find h. The next part is dealing with some graphs. So we have to graph this equation here, 3x minus 6. All right, we can do that. So we're going to make a table first. And the way you graph a graph so far is we just plug in values for x and get out values for y. So we could plug in any value you want for x, but our graph only goes up to 10. So I'd recommend we keep it below 10. So maybe we can try 3. If I plug in 3, let's do this real quick. 3, plug in 3. So again, this says take out the x and put in a 3. 3 times 3 is 9, minus 6 is 3. I could plug in a 4. So 3 times 4 minus 6. Because remember, my equation originally is 3x minus 6. So here I replace it with the 3. Here I replace it with the 4. In this case, I get 6. I could do another one like, say, 5. So 3 times 5 minus 15. Or sorry, minus 6. I'm not sure why I put 15 there, even though I wrote 16. So minus 6. So 3 times 5, that's 15. Minus 6 would give you 9. And once you have about 3 or 4 points, you can just go ahead and plot them. So this first point is 3, 3. So over 3, up 3. There's my first point. Next one's 4, 6. So over 4, up 6. There's my next one. And the next one's 5, 9. So over to 5, up to 9. My next one. And then that right there would be my graph. You can just draw a line through those points, draw some arrows at the end, and then there's your graph answer. So again, all you had to do is plug in numbers for x, get out numbers for y, and there's your graph there. And you can choose whatever numbers you want for x. I would just keep them low so that you can know how to work with them. If you make them too high, they're not going to fit on the graph, and they're going to be a little hard to work with. The other one here is going backwards. So you're given a graph, and you need to find the table or the equation that goes with it. Usually you have to find the table first and then find the equation, but you don't necessarily have to. So let's put these points on a table first. Let's make a table first. So this one says 0, 2. So 0, 2. This one's 1, 3. So 1, 3. 2, 4. 3, 5. And 4, 6. And I want to know what the rule of this table is. Well, if we look here, I'm going from 0 to 2. So 0 to 2, 1 to 3, 2 to 4, 3 to 5, 4 to 6. We think to ourselves, what's happening each time? Well, it can't be multiplying. It's probably adding. In this case, it's probably adding 2. 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4, and so on and so forth. So my equation is x plus 2 equals y. Because that's how I get from one x number to the other y numbers. I take my x number, I add 2 to it, and then I get my y value. So that's the rule for that table, and that's the linear equation for the graph. So the rule for a table and the linear equation for a graph is the same question in our case. So if they ask you for a linear equation, or they ask you for the rule of a table, or if they ask you for an equation in general, it's all the same thing. The next step is kind of review from past chapters. So the first one there, 2/9 x equals 11, or sorry, equals 10. We want to solve for x. I'm actually going to rewrite the problem over here, so I have a little bit more room to work with rather than having it right next to the edge of the screen. Now there's a few ways you could do this. For example, your goal is to get x by itself, so you could remove the 9 and the 2 separately by doing opposite operations for each one. So for example, this says divide by 9. If I want to get rid of dividing by 9, I could multiply by 9, because multiplication and division cancel each other out. So I could multiply both sides by 9, like this. And then these two 9s would cancel out. I'm now to be left with 2x. And here, 10 times 9, well, that's 90. So the multiplication canceled out the division over here, and the multiplication gave me 90 on the other side. Now I just have a 2 left, so I can get rid of that by dividing. So divide by 2, and I get x equals 45 as my answer. So I kind of did it in 2 steps. I got rid of the bottom number by multiplying, and I got rid of the top number by dividing. There are a few shortcuts you could do here, and I'll let you figure those out if you want, but this is a perfectly okay way of doing it for now. Is you get rid of the bottom number by multiplying both sides, you get rid of the top number by dividing both sides. That way you have just the x left over, because that's your end goal when solving any equation, is to get your variable by itself. Number 12 is much more straightforward. 3 times x equals 18. I want to know what x is. Well, that's just as simple as dividing by 3. And you get x equals 6. Because the reason we're dividing is to get rid of the multiplying by 3. So to cancel out multiplication, you got to do division. The next two are a little bit different. This one here is another equation writing question. So it says we have x eggs in a basket, we double the amount of eggs, and then we add 5 more. And we want an expression showing how many eggs are there in the basket right now. Well, let's write down what we start with, x. We doubled the amount of eggs in the basket. Well, that means we're going to times it by 2. That's what you do when you double something, is you times it by 2. So we start with x eggs, we double it, so times by 2. And then we add 5 more eggs. So add 5 more eggs. And this would be the expression of representing how many eggs are in the basket. So when you have this type of problem, what you want to do is kind of write the variable you start with, and then you just go through and saying what's happening each time. So first you double, so times by 2. Then you add 5 more, so add 5. And then there's your expression. The bottom one here was from a while back, combining like terms. There's a few steps involved in this one. So the first thing is that this 5 on the outside is being multiplied to the x plus 9. And that x plus 9 is in parentheses, so it's going to be kind of important here. Now, normally what we would do is we would do x plus 9 together, but we can't because one's an x and one's a 9. You can't add an x and a 9 together because one's a variable and one's not. So the way we kind of go about this is we take this outside 5, which is right next to the parentheses, and we multiply it to both the inside numbers. It's called distribution. Because what that 5 is it says 5 times x plus 9, because it's right next to each other. Remember, when numbers are right next to each other, that means multiplication. So this is 5 times x plus 9. But because I can't do x plus 9 itself, I'm just going to take 5 times both of them separately, because I just can't add them together right away. So this would be 4x down here, and this would be 5 times x is 5x. 5 times 9 is 45. So again, I multiply the 5 to both numbers on the inside. When you multiply a number to a variable, all you do is you just multiply the coefficients and keep the variable the same. So if I have 5 times 1x, that's just going to give me 5x. And then you combine the like terms. In this case, I can put my two x's together, and that will get me 9x plus 45 that I just bring down. So there would be my simplified expression, 9x plus 45. Simple as that. So when you have a number right outside the parentheses, and you can't add what's inside the parentheses. You have to distribute that outside number so that you can progress through the problem. The last one is the longest type of question, for good reason, because it has you do a lot. So if we read this here, we have after 1 hour, Sue has $5 in her wallet. 3 hours, she has 7, and then after 5 hours, she has $9 in her wallet. So I think I said that first one wrong. So 1 hour, she has $5. 3 hours, she has 7, and after 5, she has 9. We want to write and graph an equation showing the amount of money and then how much money she'll have after 24 hours. And it should say the amount of money, not patter. So that's just a misspelling there. It should say the amount. And then use your equation to find how much money she'll have after 24 hours. So it's a lot to do. So let's take this down step by step. We first need to write an equation and graph the equation. Well, in order to write an equation, it's good to have a table because we can make equations from tables a little bit easier. So let's do that. So I'll put x and y. Actually, let me do this. Let me put time in hours, and then we have D for dollars. Okay, so H and D. So after 1 hour, she has $5. Okay. After 3 hours, she has $7. Okay. After 5 hours, she has $9. Okay. Now we need to figure out an equation from this graph, or from this table rather. Well, let's look here. 1 to 5, 3 to 7, 5 to 9. What's happening each time? Well, if we look carefully here, we can see that it's actually an addition problem. 1 plus 4 is 5. 3 plus 4 is 7. 5 plus 4 is 9. So my equation is the dollar amount is equal to the hours plus 4. That's what this equation is showing me, is the hours plus 4 gives me the amount of dollars the person has. Then we need to graph this. Well, luckily we already have some points on here. We have 1, 5, 3, 7, 5, 9. So let's go ahead and do that. 1, 5, 3, 7, and 5, 9. I can draw my line from there. So the graph really isn't that big of a deal because all you need to do is take the points from the problem. And if the problem gives you a bunch of points you can work with, just go with those. And then the last question says how much money she will have after 24 hours. So this key part here being after 24 hours. So 24 is an hours number, so it's going to be put in for H. So it'll be D equals 24 plus 4. Again, I just replace 24 for H and put it in the problem. And 24 plus 4 is 28, so she'll have $28 at the end. So this, again, required a little bit of work because you had to go through 3 diagrams, 1 table, 1 graph, and 1 equation. So there's a lot to kind of cover there. But it's usually following that pattern. You're going to read your problem. They're going to give you a set of numbers that you can use. You're going to take that set of numbers and make them into a table. Then you're going to take that table, make an equation. Then you're going to take that table, make a graph. And then you're going to take that equation and plug in a number and get out the corresponding value. In this case, I plugged in a number for H and got the value for the dollars. So that's the general outline of the test coming up. Hope you enjoyed the video. Have a good day.